we have already seen SN curve can be represented by trilinear, right, from 1 to 10 to the 6, and your S1000 means it corresponds to the stress level correspond to 10 to the 3. That's why it's called S1000. And of course, this is the slope and low cycle fatigue, high cycle fatigue. That is all we have known. The fact is, since what are the major parameters? There I have already listed so many factors, but what we will be covering is majorly the one which is quantifiable using empirical formula or knockdown factor. One can find out the what is the factors to be used for endurance. We are talking about endurance limit. Please see here. 10 to the 3 is remain. Your endurance limit is getting affected due to the load, due to the size, due to the surface. But reliability is a parallel shift. But this load but doesn't affect at 10 to the 3 and doesn't affect at all at 10 to the 0. This is a one cycle. But when you are talking about high cycle fatigue, subsequently always you will be referring to 10 to the 3 to 10 to the 6. Then this will get the affected only endurance limit. But
Sir,
when
can
comes
you
to
hear?
yeah,
Sorry to
Sir, I have a
interrupt you.
question.
sure.
Sorry, you were continuing, so I
No, no,
didn't
no, no.
interrupt. I just raised
I
my.
told you now. You can stop me
Yeah,
to
yeah,
ask.
sure.
Yeah, yeah. No, don't
Yeah,
feel sorry about
sir.
that. Yeah.
Yeah. So on the, I mean, in the stress life approach, so I think as you were showing in couple of slides before, we have a mean stress, right?
Hmm.
And in the SN curve. So any mean stress correction factor, do you think should be applied, for the fully reverse loading or the
No, no.
non-zero
Fully
mean
reverse is
stresses?
mean stress is 0.
Yeah, but I mean, let's say, sir, as we know that many of the SN curves are generated for the fully reverse loading, right? But in practical scenarios, most of the component they go for non-zero.
Yeah, yeah.
So any mean stress correction is needed in order to have a
Obviously, it is
non-converge.
required. That will come. The effect of mean stress is one of the subtopics. How
Okay,
to take
okay.
into
So you are
account.
going.
Yeah.
Okay, okay. Thank you, sir.
You can stop. There's no issue. Don't worry about time. If you
Yeah, yeah.
expect
I was just
another one
worrying
week.
because,
Mm.
yeah, sir, when you were explaining that, I was worrying because the result could be, conservative and unconservative in terms of what you use.
No, that
So
will be
it could.
wrong unless you take a thing. We'll come to know because is positive mean stress will have detrimental effect.
Exactly, yeah, and
Mm.
compressive will have different. Yeah.
Yeah.
Okay. Thank you, sir.
Sir, if you don't mind, can you slow a little bit down?
Okay. Fine. Because I just go by flow. Okay. Don't
Yeah, I
worry.
know that.
I'm
Yeah.
okay with that. There's not worry.
And
Okay,
sir, one
thank you,
more
sir.
thing is most of, I think, some of the audience in this are, I think, some of them they have very little or no experience on fatigue. So for them, it could be little hard as well.
No,
That's
that's why
that's
I'm
one more
going
point I want to bring.
explaining in the basics. I'm starting from
Yeah, yeah, sure.
scratch. Actually, I'm doing it. So I know that I've gone through like Saas bhi kabhi bahut hi, right? I've gone through that. Okay. So
Yeah,
Yeah,
only
yeah.
the difference
Thank
is
you,
I
sir.
got 35 years experience in this line. And
Sure,
I
sure,
yeah,
know
sure.
for a stress engineer to execute an FNDT project, what is the basic things required? I will be teaching
mm,
that much. Like a
yeah,
stress
Sure.
inspector is a fracture mechanics is a very vast and complex subject, but you don't need that. Which all are available in the database and all. But you should know what is that and all. So
mm.
I will take care of that. Yeah, okay, I'll go
Thank
slow.
you,
It's no problem.
thank you,
So
sir.
now coming to the stress generator, that is earlier when before invent of computer-based servo hydraulic axial testing machine. They used to do, even people who have studied BTech mechanical or aero, they used to have a workshop. There might be somewhere sitting with the rotatory bending machine to show how the SN curve is generated. But nowadays, whether you refer to ES2 data or MMPDS, you people know, have you used MMPDS? This is
Yes,
Mill
we
Yes, sir,
Handbook.
we did.
Mill,
regularly we use, yes.
earlier it is known as Mill Handbook H, 5H.
Mm.
So those are generated in Excel loading thing. But this is showing as a special case when it is rotating bending, and they use a standard mirror polished. I hope mechanical people know what is the mirror polished. There is certain SOPs, the standard process how to make it reflection thing. That is required to
Reflection, yeah.
ensure, because as mentioned earlier, fatigue is a local surface phenomenon dependent. When you're doing a testing, if you have a different surface condition, you have a lot of variation of test result. It's difficult to correlate. That's it, to ensure the consistency. in the number of specimens you're doing it, you do a mirror. So this is a mirror policy size and fully bending reverse. So that is the top you get as a ideal condition. But when you want to do prediction, life prediction of a component, it is and it might be subjected to axial, not bending. Then you have to have a knockdown factor. If it is size, the size what you use is what? Round, circular, rotating of 1/4 inch or 6.25. But in actual structure is different. It may not be round. It may have a cross section of square, rectangular, C section and all. It may not be rotating, it's stationary. So that counts size and thing. Then surface finish. Depending on the type of machining you do, roll cold, hot cold, or grinding and all, that affects the endurance limit. But when it comes to reliability, so these are given lower size surface and temperature also there, and they are quantifiable. That subsequently I'll tell. This is the representation of that. Every time there is a change, you have to have a knockdown factor. So it keeps on decreasing. But when it comes to reliability, it affects both 10 to the power 3 as well as 10 to the power 6. So there will be parallel shift. The reliability, like you have a 24 karat, a 99.999, you want a result to be more robust and represent giving result to be 95% of confidence with 95% repeatable like that, then you have to use factor. That will come down to depending on how much you whether you want 9.99 or you want 99.99. So that factor will be there. That has to be applied there. So there is a variable like size, type of loading, surface finish, surface treatment, temperature and environment. And this again narrative, your endurance limit is 10 to the power 6, and it is also known that to get a 10 to the power 3, the stress at 10 to the power 3 for ferrous material is 50%. I'll show you more detail down the line. But endurance limit at 10 to the power 3 has to be modified. Your 10 to the power 6 point, there is nothing, no changes occur due to their load, sizes and surface finish, only the endurance limit. And non-ferrous, there is no endurance limit. For that you have to consider usually 5 into 10 to the power 8 to apply your correction factor. So tensile mean stress, large section size, rough surface finish, chrome and nickel plating, decarbonizing, severe grinding will reduce also endurance limit. Endurance limit is increased by, of course, there are process because as a mandate or requirement that it has to go through some plating and all, but that will affect your surface, but there's a way to improve it. So basically the approach, stress life approach is known as, it will give the total life without distinguishing crack initiation or from crack propagation. I will go more detail down the line. Always the fatigue, you whenever sees a fatigue life means it is due to subjectively fatigue loading. But in the process, crack will initiate from micro to macro, then it will go to the crack growth, propagation and failure. Then it usually requires that the test data relate to the geometry and the structure under assessment. This is very important to remember. We will come to know. I will tell you at the middle of that justification why you have to preferable to have a SN curve for the particular component. Because when you are doing the prediction of a component fatigue life, referring to SN curve, your SN curve is a material SN curve, not the component. But if you have SN component available, then nothing like that. You can directly use that SN curve without any going through all the modification factor. If what you are using SN curve which is a material, then you need to do. This is required to improve the accuracy in result. Plus, always there will be a requirement to correlate test results with the analytic. Whether you do hand calculation or FEM analysis using the commercial software. But how do you match? There's a difference. You know that the machine component has undergone so many processes. Unless you take care of this correction factor, you cannot come close to the testing thing. So that's a required from both the point. Material SN curve may also be generated from smooth specimen test data. They are subsequently modified to reflect the effects of notches, surface condition, etc. So, and also, yeah, ES2 data. Have you, any people have used ES2 dot engineering science data unit during any work packages?
Yes,
Okay.
ESD DSDU we have used, yes.
So there you will find, of course, it covers so much domains, not only fatigue, and endurance curve is available for the half wing also. This endurance curve is available for the log, for specific component level, but majority thing will be available is the material SN curve. So the emphasis or driving point is it's preferred if you have the SN curve available for that particular component, and then nothing to worry about. Your prediction will be as accurate as possible, and there is no conservatism in that. So the person Marin who found this effect of parameters to SN curve is SE, that is the actual endurance curve of the component, will be your S test E is the what is generated through the testing. Whether you do axial or you do the bending or do torsion, whatever the testing, because there is a testing is a specimen for the given material. Whether you use a duck bone specimen or a round specimen or whatever maybe, but that needs to be modified with so many factors, A, B, C, D, just to limit to one. A is called surface condition modification. So sometimes subsequently my slide will be showing C. Somewhere somebody who is maybe something. The fact that it's a knockdown factor, whether it is represented by K or C or any other thing, doesn't matter. But there should be knockdown factor due to surface condition, then be size modification factor, then load modification factor, temperature modification factor, relative. So this is the why I'm leaving, and the remaining is called KF, miscellaneous effect. There will be other thing which I will explain you. People who are familiar with aircraft structure, there is a skin pocket, they do some milling, chemical milling and all. Okay, so A, B, C, D, E, they are all quantifiable. So in that case, one can find the factor, but some cases which is not possible, either you have to, of course, for Airbus or Boeing, they have already generated, is available in their database in the software, whether it is Excel based or ISAMI or SAFE. There are so many software they use. So, but now they generalized to focus on the ISAMI. But in the commercial based thing, whether you're using Abacus, ANSYS or Nastran, they have a different model. So they have to, you have to take care of this model, and this is empirical relations available to do that. For miscellaneous, it is a case by case basis. You have a domestic project. If you want to do it, obviously, the engineering judgment can be done, or you have to generate the thing to justify that. Whereas this E I was telling now, this is related to the specimen endurance limit generated, and this is what actual endurance limit. I will show you the example how important to consider this thing, otherwise you will go wrong.